Hi, good morning, everybody. Can everyone hear me okay? Okay, great. We're going to get started here, so as people come in, please try to grab a seat. Thank you all for coming to this session today, and we're going to get started now. So this session is scaling up to your first 10 million users. Hopefully this is the session that you were looking to be in. Here you are. So my name is Chris Munns. I'm an AWS Solutions Architect based out of our New York City office. I work with a lot of companies of all different shapes and sizes. Primarily a lot of startups, both in New York and on the West Coast and kind of everywhere in between. And I put this talk together actually a little bit over a year and a half ago at first, and talking to some VC meetups and startup meetups. And since then, it's actually been a very popular talk. And so we're redoing it again here at re:Invent. And ideally here, what we're going to be talking about is some kind of different patterns that you could take for scaling up an application that you might be building from scratch, or maybe one that you're modifying or adapting that you've already created and are now looking to run on AWS. So we're going to be talking about some kind of general best practices, general patterns. It's by no means the be-all, end-all way to do things, but hopefully it gives you some food for thought. And so if you find yourself like many companies or many small startups or teams that are looking to build an application, you might ask yourself, how do we scale? All right, how do we go about scaling and being prepared for scale and being able to potentially deal with the hopefully high success that your application, your site, whatever it is that you might be building or making could hopefully draw. So the other thing is that many of us are not experts at this. For many people in many organizations, scale is something that they don't really see at a huge size. And so again, you might not be aware of what some of these practices are. And you might find yourself just trying to kind of guess at what you should be doing and which direction you should be taking. If you're like many people I know, the first place that you're going to go is your favorite search engine and type in something like scaling on AWS. Pretty straightforward. Hopefully you come up with some good results. But what you find from this, at least in this search engine that I'm using here, is that there's a whole lot of things to read. So I took this screenshot a couple weeks ago. At this point, there were over a million results that came back that dealt with scaling on AWS. That's quite a few, probably more than we're looking to read in an afternoon or a couple of afternoons worth of time. And one of the other things that you'll notice here is that the first two results that we get are actually not the best place for us to start. So you'll see here that we're referencing autoscaling, which is an AWS service, part of EC2. And autoscaling, while it's a fantastic service and has a lot of really, really great capabilities that you should definitely make use of, it's kind of more of a tool and a destination than a one-click checkbox or something that you just do and then everything is fine. And so there are a lot of things that you need to have before you can go into autoscaling that will enable you to make best use of something like autoscaling and enable you to be able to scale up to meet whatever the needs or demands might be of your application or of your website. So what do we need first? I think it's always good to start with the basics and kind of build our way up from there. So starting kind of at the, I like to say the International Space Station view on down, is that here at AWS we have a concept of regions. If you just saw Andy's keynote, he talked briefly about this. We think about it a little bit differently than some of the other cloud providers out there. So today we have 11 of these regions. We recently launched a region in Frankfurt in Germany a couple weeks back. And then the rest of these globally distributed. We have a region for US government customers. We have a region in China, and then the rest that you can see here on the map. Inside of those regions, we have a concept of availability zones. You can think of availability zones as independent plots of land where there's one or more physical data center inside of it. And the idea is that we build these availability zones 5 to 15 miles apart, such that they're usually on different floodplains, different fault lines, relying on different power grids, and all have their own independent Tier 1 ISP connections. The idea being here that when you build an application inside of AWS, you want to be building and deploying across multiple AZs. This is kind of a fundamental building block of building applications to scale on AWS. So again, availability zones, a very, very core, important component of infrastructure here at AWS. We also have edge locations around the globe for our CDN service and our DNS service, Cloudflare and Route 53, respectively. Over 50 of these today around the globe, and more of these kind of coming online periodically. We've definitely added quite a few this year. I'm sure you'll see us continue that trend over the future. So that's kind of the large view looking globally down. What exactly is it that represents this infrastructure? Today you can kind of think of it as 4 different categories: applications, platform services, foundational services, and then the actual global infrastructure that I just covered. This diagram is unfortunately very out of date after this morning. If you saw Andy's keynote, there were a whole lot of things that we had announced. I guess I'll be updating the slide again in the near future. But what you can see here is how the services are broken down. So again, starting at the bottom, working our way up, we've covered regions and availability zones, CDN, and points of presence. Building on top of that are kind of our core foundational services, compute, storage, networking, and security and access controls, each of which are actually made up of collections of other services underneath them. Then on top of that, we have the platform services. These are all the higher level application services and management offerings that we have, including things like databases, which today we announced Aurora, a new version of a database component inside of RDS, or database engine. We have a NoSQL database, DynamoDB. We have caching via Elasticache. Through analytics, we have a whole suite of tools. For app services, again, a whole suite of tools. Deployment and management, obviously a number of great things released today or announced today, including code deploy, code pipelines and repositories, and then mobile services, which this past summer we added capabilities with something called Cognito, which allows you to do user management and session management and syncing up of data between devices. And then on top of that, we have virtual desktops via workspaces, and then we have Zocalo, which is a document sharing and collaboration service that we also launched this summer. So a whole bunch of services that you could pick from to build your applications and build your infrastructure on top of AWS. But let's even go a little bit lower down and starting at the very basics. So starting from day one, user one, essentially you. So if we were starting out from scratch building on AWS, it might be very, very basic infrastructure like you see here. We have essentially Route 53, our DNS service, which now can host your whole domain, do domain registry, and serve up your DNS records. Serving our DNS record for our website, and we're pointing that DNS traffic at an elastic IP, essentially a static IP address that we can dynamically attach or reattach to EC2 instances. And then we have a single EC2 instance. So like many people developing an application, you start out on a single server, a single instance, and in that case, that's exactly where we are here today. And our entire application stack, web, app tier, database, management, whatever it might be that you might have, could live on this one instance. And so in terms of scaling this instance, there's really only so many directions that we can go. So we could go vertical, right? Get a larger instance size, of which today there's over 20 different instance types inside of AWS, with a mix of high CPU, high memory, high storage throughput, high storage space, and GPU options. And so you can actually go pretty high here and pretty far in terms of the capabilities of that single server. And so you might find yourself going up to the largest size instance that we have. Again, we have some that have 32 plus CPU cores into the hundreds of gigabytes of RAM and many terabytes of SSD type options that are out there. But at some point, what you are going to run into is if you do go scaling vertically, is that you're going to run into an endpoint where you're either going to have to wait for us to launch another instance, which while we do that quite regularly, it's not something that you yourself would want to be predicting against, or you're going to have to come up with a different solution beyond scaling vertically. So again, vertical does take you pretty far, but at some point you do hit this endpoint. So if we go back and think about our infrastructure stack that we have here, a very basic application, again, we could get into a few hundred to maybe several thousands, maybe even tens of thousands, although maybe not, of users depending on what our application is and the complexity of it and what's going on under the hood. But there's another number of other kind of downsides here to this application architecture. We have no failover, we have no redundancy, going along with no failover. We really have too many eggs in one basket, right? If we have our web tier, our app tier, our database tier, all running on the same host, we're potentially dealing with resource conflicts, with things taking memory from other processes and so forth. And so it's not really a super efficient thing for us to be doing. So what we really should do is think about separating out this tier. This is where we begin to break out our application into distinct components. So separating potentially our web and app tier from our database tier might make a lot of sense. And when you're thinking about that database tier, you might go and ask yourself, maybe we should make use of a database service. Again, unfortunately, a kind of out-of-date slide here today, as we did just announce RDS Aurora. But beyond that, there actually are a number of different options that you have here at AWS. The first one that I'll highlight is that we always want to make people understand that the idea here is that AWS is meant to be flexible. At the end of the day, on an EC2 instance running Windows or Linux or OpenSolaris or FreeBSD or whatever machine image you want to put on it, you can run pretty much any database that you want to. Whether it was Oracle, MySQL, MS SQL, Postgres, DB2, you name it, people are running it on EC2 themselves. And so self-managing a database is definitely an option. However, if you're a small team and maybe you don't have a deep wealth of database management experience yourself, you might want to look at something that's more of a managed service for you. So in AWS, we have a number of different options here. We have RDS, Relational Database Service, which is a managed relational database offering. When we say managed, it's important to understand what that window is inside of that management. So what RDS helps you out with is things like built-in nightly backups, point-in-time recovery, patch management of the OS, patch management of the database engine, providing configuration management in the form of parameter files that you can kind of control via the console and API. Things like read replicas, which we just added read replicas for Postgres earlier this week. The ability to do things like cross-region replication in some of these database engines. And then again today, Aurora that we just announced, which is a very, very high-scale MySQL compatible database option, which if I was starting from scratch is actually something that I would definitely be interested in looking at. Next to that, we have DynamoDB, which is a NoSQL database that we launched a couple of years back now. And DynamoDB, we like to say, is a zero administration database. What that means is that with DynamoDB, the only thing that you need to do when you're configuring it and setting it up is tell DynamoDB how many reads and writes per second you want it to be capable of. This could be 100, it could be 10,000, it could be 100,000, it could be hundreds of thousands. And behind the scenes, DynamoDB is going to take care of all the hardware provisioning, replication of that data, potentially partitioning that data behind the scenes for you without you having to worry about doing anything while delivering a consistent performance to you, usually in the low single-digit milliseconds of response time. And again, that consistency of that performance is going to remain the same whether you're doing 100 queries per second, 10,000 queries per second, or 100,000 queries per second. So a really nice option in a non-relational database for you to use. And then lastly, we have Amazon Redshift, a data warehousing service, which we also launched about 2 years ago now. Incredibly popular option that we have if you're looking for a data warehouse. With Redshift, again, you're not paying for what you typically would with a data warehouse, which is a lot of upfront licensing costs, needing to predict what your capacity needs might be at the end of the year, something like that. Instead, with Redshift, you provision it by individual nodes, and you only pay for the nodes that you're using. And at any point in time, you could double the size of your cluster, triple the size of your cluster, turn it up, turn it down. So again, a very flexible option. So again, it's my recommendation to go with a managed database. I do think it makes a lot of sense. But then the next question that you have to ask yourself is, how do we choose which database technology to go with? And this kind of borders on a religious conversation in many circles when you're thinking about whether I want to go with traditional SQL-based databases or non-relational databases like DynamoDB. And while many people may not like this, I am actually a very strong proponent of recommending SQL databases. And again, this is something where a lot of people will say, well, no, I can't work with SQL. It's not going to work for my app. It's not going to work the way I need it to. But the reality of it is that SQL is actually a really fantastic place for you to start with a new application. SQL, again, very well-worn, well-established technology. Lots of existing communities, code, books, training options out there for SQL-based databases. You really aren't going to break SQL-based databases in your first 10 million users. This argument gets even stronger with the announcement of Aurora today. Again, massive scale database that you can run via RDS without having to do much work yourself. And then there are really clear patterns of scalability if you do go with a different database option. So if you went with MySQL or Oracle or SQL Server, there are a lot of companies that have brought these database engines to scale. And so you're not going to necessarily have to go and reinvent the wheel on how this would be done. And again, up above here in the third bullet point where I say that you're not going to break SQL databases, there is that little asterisk there where I say that unless you're doing something really, really weird with your data in terms of how you're accessing it, or you have massive, massive amounts with it. So the reply to that usually is, well, I'm going to be really successful, and so I am going to have massive amounts of data, and so I should just start with a non-relational database. And I like to quantify what massive means. And in the cases that I've seen when I've worked with companies, how I define massive is data that is going to be in the terabytes very early in your business. It might be in the terabytes in 3 years, 5 years. Right now, this year, you're going to have a terabyte of data inside of a database. At that point in time, and again, depending on the velocity and change of that data, it might make sense for a non-relational database. But otherwise, starting with SQL is actually a very good path to take. Again, why are some of the reasons that you may want to go with NoSQL? There's a number of different use cases that do just generally fit non-relational databases. Things where you have super low latency applications, where Dynamo plays a really good fit because of the speed that it offers behind the scenes. Metadata-driven data sets that you might have. So for instance, if you were collecting pictures and serving pictures out and you need to store metadata about them, a non-relational database sometimes makes more sense than a relational one because there's very loose relational constructs between that data. Again, highly non-relational data, what people would refer to as schemaless data sets. And what I always like to say is if you have an application that's generating data, you are defining a schema. Even if you want to say that there could be values that may not exist in that data, that's just called a null, and it's been around for about 40 years now. So understanding exactly what it means when people say schemaless and what schemaless means to you is a really important part about understanding what database technology makes the most sense for you. And then again, massive amounts of data, where you're dealing with a whole lot of ingest, a whole lot of data all at once, is another good place for a non-relational database. So let's go back here to our application architecture and say that we are going with a relational database. In this case, we'll use RDS, maybe making use of Aurora, again, which was just announced today, or MySQL, SQL Server, Oracle, or Postgres. So we'll split that up, and we'll allow MySQL to do it for us. And then in addressing the high availability and failover that we need to in this stack, RDS actually helps us out quite a bit. So RDS supports functionality called multi-AZ. Pretty straightforward. Following on what I was talking about earlier, this allows you to, with a single checkbox, set up a highly available database server. Technically, it's two servers behind the scenes, but to you, it just looks like one, essentially, into your application. And with this, what you end up getting is a single DNS endpoint that your application needs to be aware of. And behind the scenes, we're able to do failover for you, usually in a minute to 2 minutes tops, and your application needs to know nothing about that failover occurring. What we also see here is that I have split up my web tier into 2 availability zones and put an elastic load balancer in front of it. So elastic load balancer, AWS ELB, as many people refer to it, is a service that, pretty straightforward, is a load balancing service. What it allows you to do is distribute traffic or requests to a number of instances, however many you might have. And one of the great things about ELB is that it scales up for you, it heals itself, and you really don't have to do much to manage it. It's pretty close to a zero administration service, just like some of the other ones that we have. I have customers that are doing 250,000 requests through an ELB, and ELB just doesn't break a sweat. So very dynamic, high scalable service for you that removes kind of some of the bottlenecks that traditionally come with running typical load balancers. I've spent many years working in data center environments, racking and stacking, and working with physical load balancers, and they have a finite, usually, amount of capability and capacity, whether it's things like SSL terminations that they can handle at one time, amount of throughput or traffic. These are things that you don't have to worry about with ELB. It will just scale up with you as you need to. So as I was just mentioning, you can do SSL termination for you, provides a number of monitoring capabilities, also supports logs that you can get, access logs from the ELB, which in a very high traffic website can actually be very helpful to you because then you don't need to necessarily collect those logs on your web instances. So scaling this now horizontally will actually get us pretty far. Again, ELB is kind of a massive scale service for you. RDS supports a number of capabilities to help you scale horizontally as well as vertically inside of it. And so if we look at our architecture now, and this is kind of a simplified version of it, what we could do here is, again, just keep adding web servers horizontally across our infrastructure. This diagram in terms of RDS is highlighting what MySQL we could do with MySQL in RDS, which is adding in read replicas. Now with Aurora, this actually would be a lot simpler. And essentially have ELB direct our traffic out to our instances, and things are looking good. And this could potentially get us into the tens of thousands, if not hundreds of thousands of concurrent users. So again, this will take us really far, but if we care about the performance of our website and the efficiency of it, there's actually a lot of other improvements that we could make in the stack. So iterating on top of this and moving forward, it makes sense for us to shift some load around. So at this point, we're serving all of our website, all of our assets, everything out of that web tier. This is actually really inefficient for a number of reasons. There's a great website out there, webpagetest.org, ties in with another website that keeps statistics about the majority of the most popular websites on the world. And what it shows usually is the content that's being served out of CDNs versus not being served out of CDNs, and content that is being cached versus not being cached. Surprisingly enough, in the first 100,000 or the most popular 100,000 websites that are out there, somewhere between 40 and 60% of content is not either served via a CDN or cached by a browser. So if we think about how we currently here have this architecture mapped out for us here, we're also not meeting that best practice of serving that data through another means. So what we should do is move our static content off of our web tier into something that's going to serve it a lot more efficiently for us, in this case S3, and then we could put CloudFront CDN service in front of that data to help, again, reduce the load on our web tier and then increase the performance of our website for our end users. Amazon S3, hopefully one that everyone in the room is familiar with, simple storage service, one of the earliest services that we launched. Andy talked a little bit today about the kind of traffic and growth that we've seen in S3 over the years. Again, massive, massive scale, well over 1 million requests per second globally, customers with just a ton of data inside of it. And essentially with S3, it's object-based storage for the internet. You write and put your objects into it. They can be served out directly, or you could put a lot of different controls in place for how that data is accessed. But it makes a great, great place to serve static content for websites, whether they be images, CSS files, JavaScript, movie files, whatever it might be. And you don't really have to do anything to provision S3. You have a bucket, which is a namespace. You write data into it. That data gets served out. And that's kind of all that you need to do with it. So we could take all of our static resources, put it in this S3 bucket, and not have to worry again about any of the scalability of that S3 bucket ourselves. There's a number of other features and tie-ins with S3. It plugs directly in with EMR, Elastic MapReduce. You could suck data into it from Redshift. You can use it as a logging endpoint for a number of our services. So CloudTrail, CloudFront, S3, ELB, a number of places that you can use now S3 as a logging endpoint for. Again, lots of different capabilities of S3. And then I also talked about what we would really want to do is put CloudFront in front of S3. So CloudFront, a content delivery network service, hosted across all those POPs that I had before on that diagram, those 50+ points of presence that we have globally. The idea being here that your content should end up getting cached in CloudFront, therefore greatly reducing the time that it takes for your end users to access that content. It ties in directly with S3 as a backend, so you can do things such as secure content delivery. And again, with CloudFront, it's the kind of thing that you kind of set it and forget it. Unlike many other CDN providers out there, you don't have to worry about commitments with CloudFront. You pay just for what you use. The other thing is that you don't have to worry about a complicated setup process for CloudFront. You can go right now today to the web console, and within minutes have a CloudFront distribution, again, making use of all these points of presence that there are and that exist globally. You can see a couple of interesting graphs here on these slides. The first one up here in the top is a diagram, which unfortunately couldn't put the actual timing in on this, talking about the difference between response time and server load for content that is delivered via no CDN, CDN with static content, and then CDN with static and dynamic content. So CloudFront today has capabilities of doing both static and dynamic content. You can do full SSL over CloudFront. You can do very low TTLs if you so need them. But the idea here is that, again, we're removing this load off of our web tier, which will allow us to have to run a much smaller web tier. I've seen customers save a significant amount of money by moving to a CDN and removing, again, many of those requests off of their actual web tier itself. Down on the bottom here, this is an actual traffic graph from a customer of ours. Enabled CloudFront, was using it in front of their website, and they experienced a very massive traffic event. And at one point, you can see here that CloudFront was serving over 70 gigabytes per second out of it for that one customer. And the customer didn't need to do anything to make that happen. They just needed to configure CloudFront. So really high-scale service to really help the performance of your web applications. So we've shifted some of that load now from our web tier off to S3 and CloudFront. Now we also care about the bottom part of this graph here, which is moving session end state information from our web tier in our database potentially to a caching tier. So in this case, what we're going to do is shift some of that potentially to Elasticache or to DynamoDB. So DynamoDB I already talked about a little bit. It's a NoSQL database. We would call it a zero administration service. A lot of different capabilities. Originally, it was just a key value store. We recently added JSON support and increased the item size up to 400 kilobytes. So with JSON support now, similar to some document databases and other JSON-based databases, you can actually have really deep documents inside of DynamoDB and be able to use those inside of your applications. Again, you really don't have to do much with DynamoDB in terms of provisioning it. You just tell it the reads and writes that you need per second. You don't have to worry about the storage aspect. And behind the scenes, DynamoDB is replicated across multiple facilities such that we can basically give you a high level of consistency inside of your database. Elasticache is another service that we have, very similar to RDS in that it is a management service on top of two common technologies that many people use today. One is Memcache, the other is Redis. So essentially with Elasticache, you get a hosted Redis or Memcache cluster that you can set up. We're removing a lot of the burden of the work that you would need to do there. With Memcache, you can have large clusters. We've actually released a number of modules for different languages to do self-discovery of those, such that if you lose a node, Elasticache actually will replace that for you, and then your application can be updated based on this discovery API. With Redis, we just actually announced a couple weeks ago failover mode for Redis from primaries to secondaries, such that you can promote a secondary on the fly with as little disruption to your application as possible. And so it makes a good place to do caching of database queries, to do caching of information coming in from your customers, to do state information, things like that. So we've shifted again some of this load around here. And one of the last options that we could do, again, because CloudFront supports the ability to serve dynamic content, is we can actually put CloudFront in front of our entire infrastructure. So not just those static resources, but actually directly in front of our ELB, and make use of the ability to do caching of some of the rest of our web content, like our HTML, at the edge inside of CloudFront. So again, much further reducing any sort of load that we might have on our actual infrastructure. So now that we've shifted some of this load around, we've removed state from our web tier, we've helped lighten up our database tier, we've moved static assets off of our web tier onto S3 and serving them via CloudFront, we can kind of go back to the beginning of the talk and talk about a service that we kind of briefly skimmed over, which is auto-scaling. So auto-scaling, again, part of EC2, allows you to horizontally scale a fleet of servers such that you could have 4 web servers in the fleet at one point, and then a triggered event can happen, and that could be brought up to 8, up to 10, up to 20, up to whatever number it might be. And then as your load decreases, you can shrink back down that tier of those servers, whatever they might be. A number of different ways that you can have these events triggered. They can be based on CloudWatch data. They can be based on timed events or scheduled events, or you can manually call these yourself via the CLI or the API. So a number of different ways to do this, and again, this is a horizontal scaling. So it's not going from a single host that has 4 cores to 8 cores. It's going from 1 host to 2 to 3 to 4, and then back down to 2 again if you need to. And if you want to think about how this can be really effective here, think of this graph here, an example of traffic to Amazon.com for a given 7-day period. Here we see some pretty predictable curves, kind of peaks and troughs that we can understand. And so if we were doing static capacity planning for this, we could draw a line above, say, maybe 15% of what we predict our peak to be, and say, OK, this is our available capacity. And actually, we have a pretty high utilization if we do this. This works well for the 7-day period, but if we were to look at a slightly different time frame, in this case, traffic to Amazon.com in the month of November, what we see is something a little bit different. So we've got these 2 spikes here. The first one could be Black Friday, and the next one, Cyber Monday, 2 of the biggest shopping days in the United States around our holiday season. And if we were to do that same 15% of capacity planning line for the month of November, what we end up having here is a whole lot of waste. Approximately 70+% of our capacity would be wasted and only utilized towards the end of the month, and we'd only be utilizing about 24% of it. But what auto-scaling allows us to do is directly map that capacity to the utilization that we need and have a much, much higher utilization rate for our resources, which means that you're paying a lot less and getting more for your money, essentially. So again, auto-scaling allows you to do this. So if we go back now, when we look at our infrastructure, this diagram's starting to get a little crazy here, but what we can see essentially is the white dotted lined box around our web tier. And while I show it split between the AZs, you could actually imagine this just being one auto-scaling group across all of our AZs. It's one of the capabilities that auto-scaling supports for us. We've still got our RDS database tier here. We've got our primary node and our secondary as part of a multi-AZ setup. We have a number of read replicas. And then we've introduced Elasticache and DynamoDB, potentially for caching purposes, as well as then still having our content being served via CloudFront, with our dynamic content coming to our ELB and our static content going to our S3 bucket. But it makes important sense here to think about that you really don't want to be doing all of this by hand, right? If we go back to this diagram here, there's a lot of things going on in this picture. And so it doesn't make a lot of sense for you to be going and sculpting this environment like a statue, right? We want to do this smart ways. So you really want to make use of automation. You want to make use of automation throughout the entire workflow of when you're working with AWS. I think if you are working with cloud infrastructure and you're doing it by hand, you're kind of defeating the whole purpose of API-driven infrastructure and treating your infrastructure as code. So tools to manage AWS resources, tools to manage your actual instances and hosts, and then tools to manage the analysis of, say, your logs, your monitoring, whatever it might be. Here we are with another slightly outdated slide as of today. But again, a number of different services that exist here in AWS to help you deploy and manage your applications. So Elastic Beanstalk, which is very close to a platform as a service. You toss your code into it. It builds out a multi-AZ infrastructure for you. Probably the best and easiest place to start out with AWS if you're a new customer. Up above that, we have OpsWorks, which is another management tool that integrates with host-based configuration management. Today, in the case that's using Chef under the hood, allows you to manage a much more complicated stack of resources. We have AWS CloudFormation, which is a template-driven service that allows you to represent almost any of the resources that you could have in AWS as a JSON-based template file, such that you could potentially do versioning control of that template file. You use it to update and manage all of your resources and be able to literally treat your entire infrastructure as code. The one thing that's missing from this diagram that makes a lot of sense now is Code Deploy, which is a service that we just launched today that also allows you to more easily deploy code across infrastructure. So if you didn't want to use Beanstalk because maybe you found it too restrictive, you didn't want to use OpsWorks because maybe you're using Puppet or Ansible or Salt or something else, and you didn't want to use CloudFormation because you didn't want to work with this templated-based system, you can now use Code Deploy to very easily deploy applications across a fleet of EC2 instances. And again, definitely would encourage you to take a look at that service. It's something that came out of us internally at Amazon in the form of Apollo, which is something that people inside of Amazon know is just an amazing, amazing tool. And then lastly, you could do it yourself, but again, ideally here, we don't want to be doing it ourselves, right? We want to be using a tool to help out with this. So at some point here, again, going back to that previous diagram where we had auto-scaling, RDS, Elasticache, DynamoDB, S3, CloudFront, you're going to start to need to run into certain things that might potentially restrict you. So some of the things that you'll start to run into is making sure that you have really strong metrics and logging in place so that you can look deeply into your application and your infrastructure stack, understand where you might be running into bottlenecks or falling short. You also, and this is the second bullet here, is a really important one. We talk at AWS a lot about our customer obsession, and we do try to listen to our customers in every single way that we possibly can, but I find that many web companies actually don't do the same when working with their customers. And sometimes finding out from your end users what their experience is on your site's load time, performance, and so forth is really important. So there are a number of tools that are out there today that can do real user management or real user monitoring of your application, see what kind of performance your end users are getting. This is a very important metric that you should be gathering. And then lastly, you can work to try to squeeze as much out of these different components as you can throughout your infrastructure based on the data that you're gathering here. Essentially, there are a number of metrics that I always think are really important. We have host level metrics, aggregate level metrics, again, of various hosts that we might have, log analysis, and then, again, external site performance. That last one being one that I'm very surprised that many companies don't pay more attention to. I find that external site performance is probably the single most important metric that you should be paying attention to versus things like CPU utilization or memory usage or something like that. The top two graphs here are actually from CloudWatch, which is a service that we have here at AWS. One on the bottom right is an actually pretty aged screenshot from Kibana, which is a log analysis tool. And then on the bottom left here, this is a screenshot from Pingdom, which is a great external tool that you can use to kind of manage the performance of your website. So there are actually further improvements that we can make now inside that web tier. Right? We've shifted off static content. We've shifted off state and session caching. Let's see what else we could potentially do inside that application. And again, at this point, we really just have a single monolithic application, so maybe we can break that up a little further. And so this is where I like to talk about service-oriented architecture. Nowadays, there's kind of a buzz in the term of microservices, which I feel is really just another revision on top of service-oriented architecture. And when we're talking about SOA, what we're talking about is the concept of moving functionality of your application into independent services and tiers inside of your overall infrastructure. And such that each of these individual tiers and components could scale individually. And this greater separation and independence of that scalability is what's going to give you better overall performance inside of your infrastructure. And if you think about how AWS works today, where we have all these independent services, again, as of today now, almost 50 services, I guess, SOA is something that we kind of live and breathe every day here. So some examples of this are things that you want to think about when you're building an SOA infrastructure. Loose coupling is kind of really the key important part that you want to be aware of, right? Your services should be very independent from each other. They shouldn't necessarily have to be so tightly tied to each other that one being out of capacity, one being constrained should negatively impact the other. If you run into that, then you're really not doing SOA well. Design everything as a black box, right, as independently, again, as possible. This is something that we do very heavily here at Amazon and AWS in all of our services, again, usually just exposing APIs to each other, but not being able to talk directly to each other on a lower level protocol, if you will. And going along with that is decoupling the interactions, and again, trying to favor services that already have built-in redundancy and scalability for you. So making use for something like DynamoDB as a place to store session state versus maybe rolling something yourself. You see a diagram down here in the example of tight coupling versus loose coupling, where sometimes it makes sense to put something like a queue in place between two tiers instead of having them interact directly with each other, which could potentially cause one to overwhelm the other. Again, loose coupling in SLA definitely helps you with scaling your infrastructure really well. And this is another point where, how I like to say that I favor managed databases, I also favor managed services wherever I can get away with them. And if you're a small company and you have a small team, try to fight the tendency to say, well, we can just do this all ourselves, and maybe it'll be cheaper for you, but you're trading your time for this versus this cost. And so, try to avoid reinventing the wheel. Again, especially as you're a small company, you're building out a new infrastructure application. When I talk about reinventing the wheel, it's building things like your own email service, queuing, databases, monitoring, log analysis, stuff like that. And actually, I've worked with startups where I've seen them build all of these things themselves. And so, try to avoid doing that as much as possible. Really ask yourself if your developers are spending time on something that is core to the product that you're building versus a nice-to-have custom piece of software that they just want to write because they find it interesting. So putting all of this together here is definitely going to get you into the millions of user range, right? Multi-AZ, again, being a foundational component of scalability and high availability inside of AWS. Using something like elastic load balancing between tiers. And today, inside of a VPC, you can actually structure ELBs internally between your applications. Making use of auto-scaling, again, when you're ready to make use of auto-scaling, not right away from day one, but kind of growing into it once you've made sure that your application tiers are capable of having instances brought up and brought down without negatively impacting your application. Think about a service-oriented architecture, right? If you have a very monolithic application that is performing all of the actions that your application or your website could perform, that usually means you might have too much bottled into that one app, and it might make sense to start to split those things out into independent tiers. Think about serving your content smartly. Again, if you're not using a CDN today, this is really a no-brainer to reducing load on your infrastructure while increasing the performance for your end users. And I've seen CDNs pay for themselves in terms of reducing load off of your end infrastructure, as well as increasing the viewpoint that customers have about your websites and applications because they're that much more performant. Move caching off of your database. I'm very surprised when I still see people do query caching local on a database. This hasn't been a good idea for a very long time. It's still not a good idea, so make sure you move that off of your database engines. And then lastly, again, moving state off of tiers that auto-scale. I didn't touch on this too much before, but with auto-scaling, again, you can scale up and increase instances, and that's great. But when you scale down, which is something that you definitely want to do, right, to match that capacity line to your utilization or to your actual application needs, you're actually turning off infrastructure. And so if you turn off infrastructure that has important data on it, you're probably going to have a bad day. So make sure that you try to avoid that wherever possible, again, by storing the state in some place that is not going to have that potential for loss. So here, again, another iteration on top of our infrastructure. In this case, we're just looking at a single availability zone view because it's too much to fit into this one slide here. What we see is we've implemented auto-scaling in a number of different places, around our web tier, around potentially a worker tier as part of an internal service that we have, around some other internal application that we might have. We're making use still of RDS with our multi-AZ master node, our read replicas. We're using Elasticache and potentially DynamoDB inside of this infrastructure. Moving our static content to S3, serving it via CloudFront. Again, serving the full site through CloudFront as well. And then maybe because we send emails from our application, we've made use of Amazon SES, which is an email service. Again, building out these independent services versus managing them ourselves on our web application tier. So what are the kind of the next big steps, the next big things that you might run into? Well, depending on the database that you go with, one of the things that you could end up is kind of a point where you're actually starting to break relational databases. Again, I think Aurora really kind of changes this conversation and this viewpoint. But if you're using another relational database engine, you might start to run into scaling issues around write contention, around the amount of read capacity that you have available. So there are a number of different ways that you can solve it. Federation, sharding, and then looking to move actually some of that functionality to a non-relational database. So talking about federation, this is really straightforward. This is the idea of moving some functionality from your application from this one database into independent databases. So in the example here, we've got different databases for forums users and for our products. Maybe this is an e-commerce website where we allow people to post reviews. And so typically we're not going to be merging that data together for any reason. And so it's very easy for us to take that data and break it out into different databases and allow our application to smartly join it for us. Again, really, really straightforward and kind of an easy scaling option to do, but at some point you end up running into the same bottlenecks that brought you into this in the first place. So if your forums on your website are super, super hot and super, super busy, at some point you start to run into, again, you're at the biggest box that you have kind of a situation. In which case, sharding starts to become a viable option. Sharding definitely can be a bit of work depending on how you end up trying to think about sharding, but a pattern that we see in a lot of places. Instagram, Pinterest, Tumblr, Flickr, Etsy, a number of websites out there have talked about their heavy use of sharding of their infrastructure using relational databases. So these are defined patterns, but they're defined patterns that have been very unique to each of those companies. In this case, we're showing an example where we have one set of information, and this information is broken up to live across these different servers. Now, what this requires is some sort of kind of master lookup database that's telling us that user 2345 lives on shard A, and user 2346 lives on shard B. So a little bit more complexity here in our application, in our architecture. But what you could do ideally here is just continue to add shards and scale horizontally via those shards pretty far out, actually. And so again, a number of really big websites these days follow this sharding methodology, and it's been very successful for them. And then lastly here, the idea that at some point it may make sense to shift some of this functionality to a non-relational database. Again, maybe you're dealing with massive size, maybe you're dealing with a very high velocity of change in that data, a very high request rate of it potentially, and so something in the NoSQL range might make more sense. Some examples here of things like leaderboards or scoring where they're rapidly updated and rapidly viewed. Rapid ingest of things like clickstream data. Maybe we're gathering records from our users very, very quickly from a mobile application, right? Where are we going to store that data? DynamoDB or other non-relational databases make a lot of sense here. Temporary data needs, so for instance, cart data. So DynamoDB came out of a database at Amazon.com called Dynamo, which was originally used for cart data, among other things. So something that has some direct lineage there to how it's used inside of Amazon.com. The concept of hot tables or really hot data inside your database. Sometimes you can kind of move a single table space to a non-relational database. And then lastly, things like metadata lookup tables, which there are actually a number of really great case studies. Amazon Cloud Drive makes use of DynamoDB for metadata information. So a quick review. Multi-AZ infrastructure, again, this is a core basic component of building infrastructure on top of AWS and applications. Make use of self-scaling and managed services wherever you can. Again, it's going to reduce the burden upon you and your organization, and it makes sense up to the very far extremes of scaling. Build in redundancy at every level, right? If you are going to manage something yourself, make sure that you're avoiding single points of failure. Make sure that you're making use of things like auto-scaling and other services that support that. Again, start SQL. I really do encourage this for many organizations. Really spend the time to think about how your data is structured, to be real about your data growth and trajectory and what might happen there. Make use of caching both inside your architecture and infrastructure as well as outside via things like CDNs. Again, really can't understate the power of CDN services. And then lastly, don't do this by hand, right? Use automation tools wherever you can and as much as possible. Make sure that you have good metrics and monitoring in place. You really can't do much without good metrics and monitoring. Look at doing SOA inside your infrastructure, splitting up those various tiers that you might have. Use auto-scaling when you're ready for it, right? Don't just start right away, day one. You may not understand some of the implications of it, and you may not have all the tooling in place to have it work really well for you. Again, don't reinvent the wheel. And then lastly, move to NoSQL if and when it makes sense for your application. Again, if you start with SQL-based databases. And then putting this together is really what's going to get you to that 10 million user mark and above. So above this is kind of my one more thing moment in the slide deck, is that again, getting over this is just going to involve more iterations on top of it. Companies that I've seen getting over this mark, they're really not going too differently beyond this except for just continuing iteration on top of it. More fine-tuning of your applications, more SOA of features and components inside your application, going potentially from multi-AZ to multi-region. Do not encourage companies going multi-region in the beginning. It's something that you really want to grow into when it absolutely makes sense for you. This is where you might actually need to start reinventing the wheel and building custom components. And then again, lastly, deep analysis of your applications and your infrastructure, really deep profiling of the services that you're building, the code that you're writing, and so forth. So next steps, lots of documentation, lots of things that you can read. Obviously, lots of awesome talks this week that you can go to. Feel free to go down to the Expo Center and hit up some of my counterparts in the solutions architecture team down at the booth. And also, start playing with AWS, right? We have the free tier, which enables many different services for you. Also ask for help. The forums, lots of awesome questions, lots of awesome conversations happen in the forums every day. Make that a part of your life when you're stumbling to figure something out or when you're trying to figure out a solution to a problem. Reach out to your account manager, solutions architect, support, whatever it might be. And we're definitely here to help. So thank you for listening. I'm slightly over on time here. I'll be taking questions out in the hallway, actually, after this session, because I know we have to open up for the next one. But thank you for your time. Thanks for coming to this session, and enjoy the rest of your time here at reInvent.